1.6, solve linear inequalities. Okay, for this first vocabulary word, I'm going to mark out the word linear. Let's just talk about an inequality. Inequality, instead of an equal sign, it has a greater than, a less than, a greater than or equal to, or less than or equal to sign. And a compound inequality are two or the more of the above joined by and or. And then equivalent inequalities are equalities that have the same solution. So example 1, we need to graph these simple inequalities. So x is less than or equal to 4. So on a number line, I need to find 4. And this time it's a closed dot. And a closed dot means it can be exactly 4. And then I need to color in one side of my inequality. But which side is it? Well, x is less than or equal to 4. So I need to color in the less than side, which is toward lower numbers. A B, or graph, x is greater than -2. This time x cannot be -2. It can be real close to -2, negative 1.999999, but it can't be exactly -2. So instead of making a closed dot, I'm going to make an open dot this time. And it's greater than that, so I need to color in the right side this time, going toward the greater side. I'll go ahead and do those 2 checkpoints at the bottom. Example 2, graph compound inequalities. Graph -3 is less than x and less than 1. So solution A. The solutions are all real numbers that are greater than -3 and less than 1. So notice that I have less than signs, not less than or equal to. So these are open dots. I need to make an open dot at 3. And I need greater than 3. When you're reading this, start with x and read toward your numbers. So x is greater than -3. Oops, and I just put the dot on the wrong spot. So ignore that dot and come over here and put an open dot on -3. And it is greater than that. Now it's also less than 1. So I'm going to make another open dot at 1 and color in toward the less than side. So my solution set is the numbers between -3 and 1, and not including -3 and 1. On B, graph x is less than -1 or x is greater than or equal to 1. So x is less than -1. Make a open dot on -1 and go toward the less than side. And I'm going to make a closed dot, since we have a greater than or equal to, on 1 and go toward the greater than side. Okay, checkpoint. Graph that inequality. Okay, transformations that produce equivalent inequalities. I can do exactly the same things that I do to a linear equation with inequalities. So I can add the same number to each side. So if I want my x by itself, I can add 7 to both sides, and I'll get x is less than 11. I can subtract the same number from both sides, and I'll get x is greater than or equal to -4. I can multiply each side by the same positive number or fraction in this case. And that'll give me, flip it over, 2 over 1 times 2 over 1. That'll give me x is greater than 20. I can divide each side by the same positive number. And that'll give me x is less than or equal to 3. Now, the only things you have to be careful of, and the only thing different than regular equal signs with inequalities, is if you multiply or divide by a negative number, you have to flip the inequality over. So, if I need to get x by itself, I need to multiply by a -1 to get rid of that negative sign. And then when I do that, I have to flip the inequality sign over. That looks like a 7, doesn't it? Write that a little better, -1. So that would be a -17. Or again, if I divide by a negative, I end up having to flip again. Flip to be -5. Example 3. Solve an inequality with a variable on both sides. So I need to get all the x's on one side and the numbers on the other side. So I'm going to write the original inequality, and I am going to subtract the 5x from both, sorry. I would subtract the 4x from both sides. And that's not what they do on my answer sheet. So again, I am going to move over here and just do it my way. So here's my original equation. 4x plus 5 is greater than 9x minus 10. Subtract 4x from both sides. That'll leave me with 5 is greater than 5x minus 10. I'm going to add 10 to both sides. So that'll leave me with 15 is greater than 5x. And divide by 5. So 3 is greater than x. Now, to write my answer in the proper way, I need the x on the left side. So I can read, I can start with x when I'm reading it. So be careful when you do this, because if you start with the x and read this way, you see how it reads x is smaller than, less than 3. So I need to actually remember to write my inequality the right way that pertains to x. Okay, to graph it, I would go over here, and I need to graph x is smaller than or less than 3. So it is an open circle, and less than is toward this side. Okay, checkpoint. Go ahead and do those 2 checkpoints, and then start the video again. Okay, example 4. Solve -7 is less than 5x minus 2 is less than or equal to 8. I can work with this just like any inequality. I just need to do it to all 3 sides instead of just both sides. So I need to get x by itself. Let's add 2 to all 3 sides to give me 5 is less than 5x is less than or equal to 10. Now I need to divide by 5 to get x by itself. And that'll leave me with 1 is less than x is less than or equal to 2. So to graph this, come over here and say 1 is less than x, so open circle, and then x is less than or equal to 2. So close circle on 2 and color this way. Okay, I have made a mistake. Did you see the mistake I made? Teachers are human too. So what was that mistake? I messed this up, didn't I? Remember I said that dropping a negative sign is the usual mistake that people make, and I did that. Negative 7 plus 2 is a negative 5. So that would change that to negative 1 here. So I'm going to go back and fix my graph over here. And instead of my open circle being at positive 1, I need my open circle to be at negative 1. And then I'm going to graph in between. Alright. Let's see if I can get this one right. Example 5. Solve an OR compound inequality. On an OR, it gives us 2 equations. So we're going to put them in what I call a T-chart. And the T-chart just gives us our 2 sides. So we're going to work at this side first. And I'm going to add 7 to both sides. And that'll give me 4x is less than or equal to 12. Divide by 4. Then I get x is less than or equal to 3. My second inequality, I'm going to subtract 2 from both sides to get 3x is greater than or equal to 21. Then I'm going to divide by 3 to get x is greater than or equal to 7. So to graph this, I'm going to have closed dots at 3, and x is less than, so I'm going to color this way, and then a closed dot at 7, and x is greater than, so I'm going to color it this way. If you wanted to check this, a good way to check it is to pick an easy number that you've said was true, such as 2, and put the 2 back in here, and make sure that's true statement back in the original equation. So 4 times 2 is 8. 8 minus 7 is 1. And 1 is less than or equal to 5. So this is a good way to check it. Okay, checkpoint. Go ahead and graph these 3. And then that's the end.